Now, up next we're going to cover how we can import other people's functions that they've written and use them in our code. Now before we get technical, close your eyes and imagine you are trying to build a house. Sure, you could grow your own trees, chop down your own wood, make your own tools and nails, and build it from scratch. But why do that, when you can simply go to your local Home Depot and buy these materials that others have already made ready for you? That's the main idea behind importing functions into your code. Importing functions allows you to gain access to libraries of functions that other people have already made for you. This is just as useful as it sounds. There are so many functions that are super useful for any given program that it would take you forever to write them all yourself. Luckily, other people have already done most of this for you. In each programming language, you are able to use an import statement to import libraries of functions into your program that you can use as you write it. A library is simply a collection of functions that all have the same theme. It may be a math library, a data analysis library, a library which translates text, or anything you can think of, really. There's such a variety of libraries for any given language that most functions you require that are not hyper-specific to your program can likely be found in some library. In fact, a good portion of any programmer's job is looking online for packages which can make his or her job easier instead of handwriting functions. Now I can hear you saying, "Wow, that's sick! How do I do it?" Well, it's quite simple. An import statement. In most languages, an import statement consists of three parts: the library you would like to import from, the package you would like to import from that library, and then which class from that package you would like to use. For example, we could load up the Java library, and from there import the util package, short for utilities, and then from that utilities package, import the scanner class, a class which allows us to read information from the user. A package is simply a smaller set of functions and methods to help differentiate between the thousands of methods contained in a library, and a class is even more specialized than that. Now, if you don't know what specific classes you're going to want to pull methods from, you can use a star to import all classes within the package you'd like. However, it can be beneficial to be more specific and only import the classes you would like, as it helps with the efficiency of the program in the long run. For instance, in Python, the syntax to import a library is import followed by the library name. However, importing an entire library is more computationally taxing than importing specific functions from a library. Imagine you would only be using the factorial function from the Python math library. It would be a waste of computing power to import the entire library, and it would increase the load time for your program. For smaller programs, this isn't a big deal, but it really starts to add up when dealing with larger projects. Therefore, you would instead use from math import factorial, or the Java equivalent import java.math.factorial, and now have access to that one math command only. This limits the functions that you can use, however it saves programming runtime. If you decide you want to use another function that you hadn't planned for, you can always go back and import that too. Many times, if you try to use a function from a common package and you have not yet imported it, the IDE will prompt you to do so. If you're trying to figure out which libraries you want to import, think of the functions you're going to need in your program. Perform a simple Google search, and you will probably run into a package or library that already exists in your IDE that you can use. And if you can't, there are ways to download and import additional projects to fit your needs. But what if, after all that, you still can't find a library that contains the function you're looking for? Well, that's a perfect segue into what we're going to talk about next, which is the basic structure for writing your own functions.
So at this point we've talked about both what functions are and how we can get some very useful functions by importing them through packages. But there are definitely going to be moments in your programming career where you're going to want to make your own functions because you want one to be made specifically to your program and code. Luckily, making your own functions is extremely simple. There are just some basic rules that I want to cover. Now, while we've previously used making functions as an example for other topics, such as the player stats function from a little bit ago, they were extremely abstract and didn't go into depth into what is needed for an actual function to operate. So right now we're going to be covering a skeletal system of everything that needs to be included in a function in order to get it to work. Now think back to the 4 different types of functions that we talked about previously. Functions that do and don't return values, and functions that both do and don't take in arguments. For creating your own functions, we're just going to have to go down the list and talk about how to approach creating each one of them, starting with the most basic of the bunch, one which takes in no arguments and returns no values. Before we start that, there are a few small things I want to note about function naming conventions. The variable naming conventions we talked about previously also translate over to function names. So you can't have two-word functions, and you can't use special characters like periods or commas. Generally, you're going to want to follow the same camel case style which we talked about in the variables video, which is not capitalizing the first word, but capitalizing each word after that. Alright, so in general for making functions, each language differentiates on how you tell the computer that it's actually a function. In Java, you have to define the function's scope, which is something you don't really need to know unless you're going to become more invested in Java, but basically it tells the computer which parts of the code can use the function and which type can't. For this series, all of our functions that we make are going to be public. From there, you then determine which type of function it is. So in this case, since it won't be returning any variables, we'll just put void to signify this type of function will not be returning anything. Finally, you put the function name after those two identifiers, along with a set of parentheses after it like so. The parentheses are where your arguments would go if you were making a function that took in arguments. But since for our first type of function, we're not incorporating arguments into this function, let's just leave those blank. All of that is just for Java. Python, on the other hand, all you have to do is put the word def, short for define, and then the function name with a set of parentheses. So as you can see, each language is going to be a little bit different in how you make functions, but the main thing we want to remember is to always add parentheses. From there, we just type what we want our void function to do within the confines of the function and close it off, and we're done. In Java, the confines of the loop would be whatever is contained within the curly braces, and in Python it would be until you are no longer indented. At its core, this is the most primitive type of function we've made, something which takes in no arguments and returns no values, quite similar to the print_stats function from early on. Moving on to the next type of function, creating a void function that takes in arguments. Now this process is going to seem very similar to the previous, except for one small adjustment. Remember the parentheses that I mentioned earlier? Well, we put any variables we want the user to pass into the function into these parentheses, and then when we call that specific function, it will be required to have those variables passed into it. For example, in Java, let's make a function that takes in two numbers and prints out the product of those numbers. We start with the public void plus name of function setup again, since we won't be returning any values. And here comes a new part. Inside the parentheses, you define which type of variables you would like to pass in as arguments. In this case, an integer, and then a name for that variable. This name is what you will use to refer to the integer that the user passes in. For example, let's just call it num1. Then, if we want to add another argument, we simply add a comma in between the two, and we can make another integer variable, num2, to hold the second number. We could do this for however many variables we want to pass into the function. But for now, let's close off the parentheses and just print out the product of num1 and num2. As you can see, we refer to the two numbers that the user will input into the function as num1 and num2. Whatever numbers that the user passes into the function will be converted into num1 and num2. Now, whenever we want to call the multiply numbers function, we just have to make sure that we are putting two numbers in as arguments. In this case, the number 5 becomes num1 and the number 8 becomes num2. From there, we simply run the code and the number 40 is printed to the console. It's pretty important to note that you can also mix and match variables when making arguments. So you can have some function which takes in a car, an integer, and two strings all within one function. The last thing I want to mention about arguments is that when you call a function, you have to follow the variables you defined when making the function. So for our multiply numbers function, you couldn't put in a string and then an int. It has to be two integers because that's what the computer is expecting to be passed into the function. So now that we've gone over how to make functions that don't return variables, we have to cover those that do. And we'll start with ones that don't take in arguments. Now the main difference between defining functions that return variables and defining ones that do not is that in some cases you have to specify that you want this function to return an integer variable. This is most common in Java, where you would replace void with int to tell the computer that you want this function to give you something back to you in the form of an integer. This works the same as if you wanted to return a string, char, or even an array. You simply replace the word after public with whatever variable you want to be returned by that function. The most important thing to remember about making functions that return variables is that no matter what path your code takes, it must return a variable, no matter what. What does this mean? Well, let's say you had some string function in a game, and inside of it there was an if statement, where if the player's score was above 10, you returned a congratulatory message. This works fine if you printed the result of this function and the player's score is above 10, but if the player's score was less than 10, then you don't enter the if statement, and then you don't have something prepared to be returned to the user, and so the function is going to throw you an error. You have to have all your paths covered, which may seem simple, but if you're making a function with a switch statement in it containing high amounts of cases, then this can get out of hand very quickly. Something I like to do to make sure this doesn't happen is put a return statement at the bottom of a function with a string or an integer so unique that I'm able to tell that the code is not running properly and can fix it. Also, usually an IDE will let you know if there is a path in your code or in a function that does not return a variable when it should. The main point I'm trying to get across, however, is always cover your exits and make sure you have a return statement prepared for any case the user may throw at you. Another small thing to note is that you can't return one type of variable if you've already defined the function to return another type. For example, you can't return a string in an integer function or vice versa. The return statement must always match the type of function, no matter what. The final type of function is one that returns variables and also takes in arguments, and for these, all you need to do is combine what we've learned from the previous cases. First, you assign your arguments in between the parentheses, making sure that you have also defined what type of variable you want to return, and then ensure that no matter what path the code takes, that you're always returning that variable type. That concludes our discussion on functions. As you can probably tell, functions are an extremely vast subject area and require a little bit of practice to fully understand, which is why later on in this series we'll recommend some websites you can use to practice those more difficult topics.